So next up, we have forced turnover, evaluating pressing effectiveness in soccer. So this project is in partnership with Daniel Wicker from Charlotte FC. So we have Natalie Race, who couldn't make it today due to soccer, from Carnegie Mellon, and with us today, we have David Almona from Center College to talk about the project. So, Almona, please take it away.
All right. Hello, everyone. How's everyone doing today? First of all, I'd like to thank the school for allowing us the opportunity to spend the entire summer with them, and also for hosting us here. And right before I start, I do want to say that I have a stutter, and I know that not a lot of people know what that is. So I just want to give a bit of context to what that is. It's basically a speech impediment that affects the speech, obviously, and it expresses itself as either repetitions, prolongations, or blockages. So you will hear a lot of that while I'm speaking, but just pay attention to what I'm saying instead of how it's being said. So we are going to talk about evaluating the pressing effectiveness in soccer. And to just start off with some key terms, because I know not a lot of people watch soccer or pay that much attention to it. So a press is basically a defensive tactic where the opposition applies coordinated pressure in an attempt to win the ball from the person who has the ball. And the idea of this is to force them to make a mistake and hopefully transition into an attack. And then if a forced turnover is the mistake that happens when the person with the ball has lost control of the ball because of a press. Now, if you're anything like me, you would want to see an example to fully understand what exactly that is. So this is a video between Spurs and City. We can see that Spurs has the ball in that defensive third, and here we see that two players are applying pressure on the ball carrier, and more players come in to apply pressure, and eventually City are able to make Spurs make Spurs turn the ball over, which is otherwise called a forced turnover. Okay, so in order to continue this project, we got our player tracking data from Skill Corner, and we had access to 520 games of the 2023 MLS season. Now, 18 of those games were unusable because they didn't pass the quality check that the company typically does, and they don't release the event data if it doesn't pass the check. And there are three types, which is similar to how player tracking comes in. There is match information, event data, and the tracking itself, which is the XY coordinates. Now, there are three steps that we took in order to kind of get to the endpoint of this project, and that is, first of all, identify when a press occurs. So in the video that I showed you, how are we able to know that was a press without looking at the video? And the next is to define the criteria for an effective press, and then look at how we do after that. So the first thing is to define a pressure zone. And initially, we defined this pressure zone as anywhere between 6 meters of the player that had the ball. But then we came across this paper titled The Visual Analysis of Football, which basically talked about how this approach doesn't account for direction, and it oversimplifies the idea of pressing. And in the paper, they then proposed this new shape. So they proposed this new shape, which isn't a perfect circle. And the formula that they used for this shape is right here. L equals to D back plus D front minus D back. z cubed plus 0.3 z over 1.3. And L is basically the maximum distance limit that the defender could be to be classified as pressing at an angle. And the angle is basically derived as a line vector from the defender to the player with the ball and from the player with the ball to the attacking direction. And this is basically a picture of what that angle is. So after we have defined the pressure zone, the only other criteria that we did was the defending player must be approaching the player with the ball at a speed of above 1 meters per second. And the reason why we did this is because we want to make sure that the defender is, is actively engaging in the press. And we don't want a case where the defender finds himself within the pressure zone but isn't, engaging. So after doing this, we were able to, and then after finding the individual pressing actions, we then grouped them into sequences where if at least one defender continue pressing within 1.5 seconds, then those individual pressing actions are grouped into the same sequence. And from this, I was able to identify 252,464 pressing sequences across the 502 MLS games. So now that we have been able to identify a press, what exactly makes a press effective? And again, this could be up for interpretation, but the idea of a press is, again, as I said earlier, to win the ball back from the player with the ball. Because in order to win the game or to score a goal, you need to have the ball. But the effect of a press should extend beyond just immediately regaining the ball, and all this is because a press could force the player with the ball into a tight place on the pitch, which could cause them to eventually lose the ball in the next few. So in this project, we defined an effective press as a forced turnover within 5 seconds of pressing initiation. And after doing so, we're able to extract 31 features, which includes spatial context, like where on the pitch the ball carrier is. Then we looked at pressing, a couple of things regarding pressing, like how many defenders are within 10 meters, within 15 meters, within 20 meters, how many options are available to the person with the ball at the time of the press. Then we looked at the game context. So is the team up by 1 goal, or are they losing the game by like 2 goals or 3 goals, and how long is left in the half or in the whole game? And then we also looked at some other situational factors. So for example, how did the ball carrier gain possession of the ball? Did they receive the ball as a pass reception from that teammate, or as an interception from the opponent, or did they receive like a low pass or a high pass or a short pass or a long pass? So all that kind of thing to account for as many things as possible. Now after that, we ran. So we're able to run five models, and we evaluated these models using a 10-fold cross validation. And to give you some information, we had tuned the hyperparameter on a 50%. We had tuned the hyperparameters for the XG boost on a 50% stratified sample of the data, because when we tried to tune it on the full thing, our computers were not able to, handle that. So we just tuned it on 50%. And this is the performance, the average performance of all the tables, of all of what we ran. And now I know that this is a lot of numbers, but I just want to point out 2 things. We can see that across the board, the average accuracy score is about 82%, or like 82.2, 82.5. But then we look at the recall, and we see that the recall is low, about 39.7, 39.4. And this kind of big change is because in our data set, there was 23% turnovers and 77% no turnovers. So because of this like big change, our model is better able to predict when a press does not occur than when a press occurs. Now, the next thing I want to point out is if you look at the average log loss score, and I guess like all the other numbers, we can see that that the models look like they perform the same. So I guess like at this point, how do we know which one to choose to continue with to make our predictions? I'm going to pick the logistic regression because it's the most parsimonious and compare it to the XGBoost because it performed the best based on average log loss score. And what we did here was we ran a z-test score to kind of see how many standard errors apart they are based on the average log loss. And from the formula we ran, we can see that the difference in performance is about 3 standard errors apart. And this tells us that based on the numbers, the performance of the XGBoost is statistically better than that of the log loss. So we continued with the XGBoost. And after looking at the team rankings, we could see that the New York Red Bulls, based on our models, forced more turnovers on average per game. And the the Nashville LC were not able to force as much. And I believe that this kind of plots could be used by a coach or by post-match analysis or post-season analysis to see how teams fared in their defensive abilities. So the next thing we did was compare our model to PPDA. And for those who don't know what soccer is, PPDA, otherwise called passes per defensive action, is the number of opposition passes allowed outside of the pressing team's own defensive third divided by the number of defensive actions by the pressing team outside their own defensive third. Now, PPDA is, I believe, one of the most commonly accepted metric to is one of the most commonly accepted metric in soccer to kind of look at a team's press, like how a team presses, and a lower figure of PPDA basically means a team is doing well with pressing, and a higher level of PPDA means a team isn't doing well. So in short, if you didn't understand all that explanation, all you just need to know is that PPDA measures pressing aggressiveness, while our model measures pressing effectiveness. Now, is there even a point in comparing this? Because they don't measure the same thing. Yes, they measure a press, but not in the same way. One measures aggressiveness, one measures effectiveness. But I'm comparing this because think about the number of goals scored and the number of shots scored. If you plot a chart of the number of shots a player takes and the number of goals they score in a season, you see a positive correlation because the more shots you take, the more likely you are to score. So the idea by comparing this is to see if there's any correlation between PPDA and our pressing effectiveness metric. And we can see that there is a good correlation. I think the correlation coefficient was about 0.5. And again, to reiterate, a lower PPDA is good. And for our pressing effectiveness, a higher number is good. So we can see that there is a correlation there, which kind of gives us a hint that we are doing something with quantifying pressure. And the next thing is to look at the variable importance. Now, we found a very interesting thing that the variable start type contributed about 70% of the total model importance. And this variable basically gives an idea of how the ball carrier got in position of the ball. Now, in Skill Corner, there were 14 categorical levels for this variable, but to simplify it for our model, we kind of grouped them into 5: reception, interception, recovery, keeps possession, and unknown. And when we looked at the actual turnover rates, we can see that the turnover rate for when the ball carrier receives the ball from an interception is about 74%. And this varies more than like the other ones than recovery, keeps possession, and receptions, which are about 15%. at the least, and this kind of is the word validate. This kind of validates what in the English Premier League in like a couple seasons ago, Liverpool and Manchester City were known to press as soon as they lose the ball. And this kind of shows that pressing as soon as you lose the ball is the best way to force a turnover because a team is probably not in the best shape and they weren't expecting to get the ball then. Now, there were a couple limitations to our projects, like the class imbalance that I mentioned earlier. We only use MLS, so it's probably difficult to get the same results from other leagues. The fact that we group pressing actions into pressing sequences means that it's hard to evaluate on an individual level, and there were a lot of missing values that we just flagged or we labeled as unknown because we didn't want to remove a lot of rows. I think we checked and like if we had removed all the unknown values, then we would have lost about 50% of everything that we had. So we just labeled them unknown or created a flag. And in terms of future work, we could include pressing intensity, we could include pitch control, and there could be some sensitivity analysis done on the 5-second forced turnover window after a press. So I'd like to thank everyone that was involved in this and that contributed in helping us do this project. You can scan the code to view our report and you could connect with us too. Thank you.
All right. Thanks, Almona. Time for one question. All right.
Hi, I was wondering if, based on your the work you've done, if it would be possible to extend it so that you could look at the specific places on the field in which teams are pressing, especially when the pressing team is pressing in the opponent's defensive third. So looking at where they're actually trying to force those turnovers and regain possession.
So in terms of the spatial context, a feature in our model, we did have a feature that looked at the third. So if it was in the attacking third, in the middle third, or in the defensive third. And when we plotted the variable importance chart, the third wasn't up there as part of the like top 15 most important features. So I'm not sure like if so I guess you could say that it's not as important as a couple of the other features. But I know that in my report I have a chart where I plotted like a heat map of all the presses that happen, and most of the pressing actions happen in the middle of the pitch.
All right, let's thank Almona.